This video will go over Unit 12, Lesson 2, box plots and outliers. After this lesson, you will be able to create a box plot, interpret a box plot, and identify outliers. A box plot, aka a box and whisker, shows a 5 statistical summary. So what you want to write down on the line on your notes is that a box plot shows the minimum, which is the lowest value right here. It shows the lower quartile, which the lower quartile, well, let me come back to that. Median. Median is the middle, the actual true middle. This is where you line up all of your numbers and you cross them off until you find the center. So the lower quartile is the 25%, is actually the middle of the lower half. So you would plot it. The median is the middle, and then the upper quartile is the middle of the higher half of numbers, everything above the median. And then the maximum is the greatest value. So what you need to write down on your line are these 5 things over here. Those are the 5 stats that a box and whisker plot shows. Something to note, this IQR is referred to as the interquartile range. If you think about range as being from the lowest to the highest or highest to lowest, interquartile range is the difference between the quartiles. So what does a box and whisker plot do? It divides the data into quarters. And even though these don't necessarily, you think of them like quarters as splitting a sandwich, we're still finding the middle. We're finding half of the middle and half of the lower and half of the upper. So we are splitting data into quarters. It displays where most of the numbers are. So we can see right here that most of our data is falling in that box. The median is clearly displayed. The the middle is very clear. This works very well for a large set of data because we can again see where all of our data points are. The problem with this is that it does not preserve the data. So if you had a particular list of numbers, you wouldn't be able to look at a box and whisker and see all of the data. You'd be getting a 5 statistical summary of that data. All right, steps for making a box and whisker. The first one is to find the median. In order to find the median, we have to arrange the data from lowest to highest. So let's take a second and arrange it from the lowest value up to the highest value. Let's see, I have a couple of 12s. That 13 can go down here. We've got a 14, the 16, and the 20. All right, so now what I need to do is to find the middle. So let me grab my pen, and to find the middle, I'm going to cross things off until I literally hit the median. Here we go, and it looks like the median is 12. So what we're going to do then, that was step 1. It says find the median of the lower half of the numbers. So now we're dealing with this lower half of numbers, and you want to find the middle there. So the middle is going to be between 8 and 9, so it's going to be 8.5. So that's going to be that lower quartile. Now we need to find the median of the upper half of the numbers. So these are upper numbers. And it's going to be between 14 and 14, which is going to be 14. So that is our upper quartile. So 14, we have 8.5, and then the middle is 12. It says plot the median, the lower quartiles, and the upper quartiles on the number line. So looking at this particular number line, and you may have to kind of do some adjusting with what you count by, but figure out how you're going to count. I have to get from the lowest value is 5 and the highest value is 20. I think I can count by ones and make it work. 1, 2, 3, 4. This one's 15. It's getting a little bit hard to write. 18, 19. Check that out. It's all going to fit. All right, so I'm going to plot the median. So the median is right here. My lower quartile is 8.5. It's right here. Let me move that word median out of the way. The upper quartile is the 14, and this is going to form the box. And then it says plot the maximum number and the minimum number. Well, the minimum is a 5, and that's my whisker, and the upper is a 20. Whoop, not super straight, but there's my whisker. So what we have is a box and whisker plot with the lower quartile at 8.5, the median at 12, and the upper quartile at 14. The lowest number is 5, and the highest number is 20. All right, so for the next one, you're also going to make a box and whisker plot. However, the data that's presented here is what's referred to as a dot plot, because if you notice, we have a number line, but we also have a bunch of dots. So instead of having to list out like we had in the previous example, and we had to put the 5, the 6, the 8, the 9, all of that in order, the dot plot is already pre-ordered. So it makes our life a little bit easier. Here are our how-to steps. First thing we have to do is find the median. Because we already have all of the numbers listed, we can go ahead and find the median by crossing off the lowest number to the highest. The lowest is a 0, highest is a 9. We get another 0, 8, another 0, 7, another 0, 5. Now the lowest number is a 1, and the highest is a 4. Another 1 and another 4, another 1 and a 3, another 1 and a 2, another 1 and another 2. So the middle is going to be between 1 and 1.5. I'm sorry, the middle is going to be between 1 and 2, which is 1.5. Now what we're going to need to do is to find the lower quartile, which is the middle of our lower numbers. So we had a 0 4 times. We had 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1. So let's find the lower of this. So we've got those to cross out, and it looks like the lower quartile is 1. Now what we need to do is find the upper quartile. So we had 2 2s, a 3, 2 4s, a 5, a 7, an 8, and a 9. So let's cross off to find the upper quartile, which is the middle of my upper values. And I ended up finding that the upper quartile was 4. And you could do that on the dot plot. I just think it gets kind of hard to cross off numbers when they're stacked. Oops, that's upper quartile. So now let's go ahead and plot it. What are we going to count by? Well, I only need to get up to 9. So let's start with 0, 1, 2, 3, 4. So 1.5, which is right here, is my median. My lower quartile is 1. My upper quartile is 4. So that's going to make the box. The minimum value is a 0. The maximum value is a 9. So there's your box and whisker. It can show you where most of the data is laying. All right, so the purpose of this next one is to look at a couple box and whiskers. It says the box plot below displays the results of a 29-question test administered to 32 students in both 2000 and 2010. So the first thing I want us to do is complete this table. It's asking for what is the maximum of the year of the test that was given in 2000. Well, the maximum looks to be 27 here. The minimum appears to be 6. Well, about 27. It looks like it might be a little bit off. I don't know, it's pretty darn close. The upper quartile is here. Looks like it's about 22. The median is here at 20. The lower quartile is here at 14. So the range would be to subtract the highest value from the lowest value, and that's going to give me 21, or about 21. And then the interquartile range is when we subtract the upper quartile from the lower quartile. So it's that 22 minus that 14, which is 8.5. Now I want us to go through the same thing and do it for 2010. Well, in 2010, the upper appears to be 28. The minimum is 8. The upper quartile is 20. The lower quartile, or I'm sorry, the median is 17. The lower quartile is 11. Oopsies. the range is the highest value, which is the 28, minus the lowest value, which is the 8, so it's 20. And then the interquartile range is the upper quartile minus the lower quartile, so that's 9. So that's our summary for both of them. It says, what percentage of the students in 2000 scored below a 20? So in 2000, let's find 20. It's right here. Notice that this is the median. Median means that it's 50%. So that means that 50% of the students have scored below 20. What percent of the students in 2010 scored below a 20? Well, here's the 20 in 2010, and notice that this is the upper quartile, so that means 75% of the students scored below a 20, and you can kind of see the way that the boxes are skewed. How many students scored below 14 in 2000? So here's 2000, here's 14. It says how many students? Well, if this is the lower quartile, then that means that that's 25%. Well, if 25% of the students out of how many students took the test? Oh, it tells us right here that 32% of the students took the test. So 25% of the 32 scored below a 14. So 25% of 32 means multiplication. It looks like 8 students scored below a 14. I think this next question is asking us a similar question. It says, how many students scored above 20 in 2010? Well, 2010 is here. Here's the 20. This is the upper quartile, which means that this is 25%, 50%, and 75%. But it's asking what percentage of students scored above that value. So even though that this is 25%, 50%, 75%, we're asking what percent scored above. So it's really 25% of the students scored higher than a 20, and 25% of the 32 means that, again, 25.25 times the 32 students that it told us in the question means that, again, approximately 8 students scored above a score of 20, whatever. All right, and then lastly, we have 2 questions left, and for the sake of time, I am going to stop this video and start another one so that I can thoroughly explain this idea of outlier. So there will be a second video.